Okay, this is 6.2 note. We are going to learn about trig functions of acute angles. We'll do some trig identities, we'll evaluate some trig functions, and hopefully solve some real-world problems. Okay, the 6 trig functions that you guys are going to need to know are cosine, sine, tangent, and then the reciprocals of those. So the reciprocal of cosine is secant, and I'll do this of this angle theta right here. The reciprocal of sine is cosecant, and the reciprocal of tangent is cotangent. Okay, easy way to remember this is each pair has a co. Obviously, you can't mess up tangent and cotangent, but sine and cosecant, cosine and secant, each pair has a co in it. That's the easy way to keep it all straight. Now, you might remember that your SOHCAHTOA. So once you know that sine is opposite over hypotenuse, then cosecant is just the reciprocal of that. So cosecant would be hypotenuse over opposite. So that's just how these work. We'll go through that again and again. So here's sine is opposite over hypotenuse, cosecant's the reciprocal of that, hypotenuse over opposite, and cosine's adjacent over hypotenuse, so switch that and you get secant, and there's tangent and cotangent as well. So we could fill out all 6 of these trig functions in terms of an example then. If we did the Pythagorean theorem, we get the hypotenuse is 5, and we could find the cosine of this angle theta is adjacent over hypotenuse. The sine of this angle is opposite over hypotenuse, and the tangent of this angle is opposite over adjacent. Now we just switch those. If you want to find secant, you'd do 5 over 3, secant of theta. If you want to find cosecant of theta, you would just do the reciprocal of sine. And if you want to find cotangent of theta, you just do the reciprocal of tangent. Now, it turns out these trig functions are actually complements of one another. You might remember this because when we graphed sine before, we learned that cosine was the same thing, we just shifted over 90 degrees. And where that comes from actually is inside of a triangle here. What you might see is that if this is theta, obviously this is 90 minus theta. So if we call this side x, this side y, and this side z, for example, what we find is the cosine of theta is adjacent over hypotenuse. Well, if we look at the sine of 90 minus theta, that would be up here, and that would be opposite of hypotenuse, which would also be x over z. So what you find is that the cosine is equal to the sine of 90 minus theta in a triangle like this. So that's the complements, and that's exactly what this says right here. The cosine and sine are complements, same with tangent and cotangent, same with secant and cosecant. Now, that's not something that you're going to have to necessarily remember. You do have to know these, though, your reciprocal identities, which is what we did up above, basically knowing that secant is the reciprocal of cosine, or 1 over cosine is equal to secant. You need to know that tangent is sine over cosine, and therefore cotangent is cosine over sine. And you need to know these 3 Pythagorean identities, which I put on your formula sheet, because we're going to use those quite a bit. Another thing to keep in mind is that we're going to write sine squared like this, but it really just means sine of theta and that quantity squared. Okay, same thing with cosine. Okay, here's an example problem then where we're given theta in an acute angle. So I'm going to draw this like in the unit circle, so to speak. And we're told that sine of this is 0.6. So we're given the y value to this point right here on the unit circle. We want to find the values of cosine and tangent using trig identities. Now the way I would do this is I would actually just make a circle or make a reference triangle here and say sine is 6 over 10, opposite of our hypotenuse to get 0.6. Then I could do the Pythagorean theorem to find this, and you'd find this side to be 8. Now I could easily find cosine as adjacent over hypotenuse, so the cosine for part A would be 8 over 10. And the tangent for part B would be opposite over adjacent, which would be 6 over 8. Now another way to do this is with our trig identities, which is what the problem wanted us to do. We know that sine squared plus cosine squared has to be equal to 1. So if we were given sine as 0.6, I can do 0.6 squared. Alright, so the cosine then is what we're looking for. So I'm just going to leave that as the cosine of x equals 1. Now I can subtract this from both sides. I could make this 36 over 100 if I make this 6 over 10 and square it. And then I can subtract that from both sides. So I end up with 1 minus 36 over 100. And this is then 100 over 100. So I get cosine squared of x equals 64 over 100, and square root both sides, and I get cosine of x equals 8 over 10, which is what we got before right here. So there are different ways to do it, and this is the way they recommend here. They also want us to find tangent, and tangent's going to be easy to find now that I have cosine and sine, because it's just sine over cosine. So in this case, we had sine was 6/10, and we have cosine is 8/10. So I can divide both sides or multiply by 10 over 6 instead. The 10's cancel. I'm sorry, 10 over 8. 10's cancel, and I get 6 over 8. And I can simplify that as 2 goes into this 3 times, it goes into this 4, so 3/4 for tangent. Now the next cosecant of pi over 8, we're going to have to do 1 over sine of pi over 8, so we're going to have to do this in our calculator. First of all, make sure your calculator's in radian mode here, and then we're just going to do 1 divided by sine of pi over 8, and we can enter in pi over 8 just like this. Hit enter, and that's going to give us our answer, which is about 2.61-ish. Okay, for application problems, just remember the angle of depression is when you're looking horizontally, you look down. That's angle of depression. Angle of elevation is when you're looking horizontally and look up. So if we're doing an application problem like this and we're standing 115 feet from something, we're looking up through an angle of 78.3 for an angle of elevation, we can find the opposite side right there by doing sine, or I'm sorry, we could do tangent of this 78.3 equals opposite over adjacent. When we multiply both sides by 115, that gives us what we're looking for y, which is about 555.3 feet. Now you got to make sure your calculator's back in degree mode for this, since you're using an angle of degrees here. Alright, let's try the homework and see if we can make some sense of this.